The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and good morning, everyone. This is Mark Carl with ControlScan, and thank you all for joining us for the webinar today. And before we get started, I want to run through just a few housekeeping items. If you could advance, Dennis. So this webinar is being recorded and will be made available in about 30 days on YouTube at the Conexxus YouTube channel and also on the website link conexxus.org. The slide deck, there will be a survey link that goes out after the webinar. If you take that survey, then the slide deck will be made available. For you participants, there will be a Q&A after the webinar, assuming we have some time left. If you would please use the questions interface of the webinar to put those questions in, we'll feed those back to our moderator and presenter at the end. Please don't ask specific questions about specific vendors. If you have any questions on that, you can email info@conexxus.org. Our Conexxus host today is Ali Russell. Thank you, Ali, for joining us. And our presenters, my name is Mark Carl. I'm the Vice Chair of the Data Security Committee at Conexxus, and also the Chief Executive Officer at ControlScan. Our speaker is Dennis Sheridan. Dennis is a Managing Consultant with Synopsys, and his email is here in the presentation if you'd like to reach out to Dennis afterwards. So a little bit about Conexxus. We are an independent nonprofit and member-driven technology organization. We set standards for data exchange, security, and mobile commerce within the petroleum market. We provide some amount of vision to identify emerging technology and trends within our market, and we advocate for our industry and technology as policy. The further webinar schedule for 2018 as it stands so far is on the 25th of January. We have this presentation from Dennis. On February 22nd, we have Thomas Duncan from Omega Systems presenting Unified Threat Management. In March, we have penetration testing presented by Sam Fansteel of Coalfire and his lab personnel. I think they're trying to put together a live penetration test, which should be interesting. And in May, we have a QIR program update from my own Chris Bucolo, who's very involved with PCI Council. For those of you who aren't Conexxus members and don't know, Conexxus has our annual conference coming up, April 29th through May 3rd at the Lowe's Chicago O'Hare in Chicago. You can review more about sponsorship opportunities and registration at conexxus.org. Go ahead, Dennis. And for those of you who are not Conexxus members here on the call, it's a great organization, and if you would like to participate and join us, then please reach out to Ali or anyone else from Conexxus or visit the website. So a little bit about our presentation today before I hand it over here. So as a lot of you who are on this webinar know, petroleum technology is very unique, more unique than any market that we know of out there. But that also means that our security is quite unique. And so what we've found as we've implemented mobile payments into this industry is that security is especially unique as it pertains to mobile payments and how we pre-authorize gas pumps. And to talk a little bit about the threats, I can tell you from where I sit that based on forensics, the threats are very real. The attackers that we're looking at are very sophisticated, very well funded, usually from organized crime organizations, and we actually have now evidence that shows that they actually have our SOC systems in their laboratories. So when you look at all of that threat together, the point there being that we're not talking about a threat that's not real. It's a real threat. And what Dennis is going to present to us is basically the anatomy of a mobile payment attack and what some of the threat vectors are and how an attacker actually might go about attacking some of those attack vectors. And with that, I'll hand it over to Dennis. Dennis, if you could give us a little bit of your background before you get into your presentation.
Sure. Thanks, Mark. Again, my name is Dennis Sheridan. I'm a managing consultant for Synopsys. I joined the Synopsys team, specifically the Software Integrity Group, at the end of 2016 when they acquired the company I was working for, Cigital. So I've been working at Cigital and Synopsys now for about, let's say, about 12, a little going on past 12 years. During this time, I've been fortunate to work with other mobile payment companies. Spent time for a couple of years running the application security group for Softcard, which was trying to make a NFC-enabled wallet for Android and iOS devices prior to the advent of Apple Pay. What we're going to be talking about today, like Mark stated, is the anatomy of some attacks specific to fuel mobile payment solutions. So with that, just going to dive right in. I'm sure if you've been to a gas station recently, you'll see that in addition to the normal, pay at the pump, card present, using your plastic card, there's some new options available. These can range from NFC enabled, which stands for near field communication, where you'll take your mobile device or perhaps, maybe some sort of little fob and able to wave it in front of the machine in order to enable your payment. But today, we just wanted to focus on QR code based mobile payment solutions. Just the move to mobile payments in general, that's been sort of precipitated by, how can we go from the plastic card world where we have a static identifier, right, your PAN, your primary account number, and go to something that, if that information were to ever be disclosed, it would not be of any use to the attacker, or perhaps it would limit the potential for fraud to a single transaction, right? Because in the world of plastic cards, once you get that number, that does not change until they cancel that card and give you a new number, right? So you're able to use a PAN if you have supporting data as well in multiple locations for multiple transactions, right? So we're going to take a look at why it's important to move away from that. And then again, specifically talk about these QR code based mobile payment solutions. We're also going to focus on paying at the pump for outside transactions, and then also for inside transactions using the QR codes. QR codes, I'm sure you have, most of you have at least one app on your phone that, if you're a Starbucks customer like myself, so you're probably used to seeing this, right? Just go to the checkout, present your barcode, it gets scanned by a reader, so these are some payment solutions that are not only in oil and gas, but in other large industries as well. So wanted to start first with just a basic architecture of the payment ecosystem, right? So everything's going to start with our mobile application. This is where your unique mobile app that your company has built for iOS or Android, and that is this is going to be what the user is going to utilize to initiate these transactions, right? It can happen, and this is going to communicate with two other parts. One is the site system, right? So you walk into the store, you present your payment app, and you can scan, right? The point of sale has got a barcode reader on it, and that is going to initiate some communication inside of the larger ecosystem. The other way as well is if you're outside, that user, their mobile phone will be communicating directly with the mobile application processor just to say, hey, I am at this location and I want to pay at this pump. That's going to be direct communication between the mobile app and the mobile application processor. The mobile application processor, this is the brain in the cloud that's sort of controlling and keeping the state of all of the transactions in this ecosystem. And this is what is going to funnel or send those transactions to the payment processor, okay, in this. For today, I want to focus on two threat actors. So one, we want to consider a malicious mobile application user. And then we also want to consider malicious site system, and we'll sort of dig into some scenarios about different types of ways that the threat actors could manifest in these situations. So let's get started with considering things on what we want to test for when we've got our mobile payments solution. We want to figure out, okay, what risks are there, that we want to make sure just to validate that we're protected from. So we're going to start out from the mobile application user perspective first. So this is an attacker. They're going to get your app, right? There's no protecting the app. It's out there. It's in the App Store, so anyone can download it. A unique thing about mobile devices and the applications that live on them are that mobile devices are, they can't be trusted, right? That the attacker controls it, and if they played by the rules and they just stuck with the normal operating system security controls that were on the phone, we might be able to trust things that we get from the mobile device with a higher degree of certainty. But as it stands, there's lots of root methods and jailbreak methods on there so that they can bypass those built-in security controls of the devices, right? So we do want to be a little bit skeptical of things that we get from the mobile device and what we store on the mobile device, because we don't want to be operating under the assumption necessarily that, it's on the device, but, it's, let's say, obfuscated or encoded or encrypted, depending on where that encryption key might live as well. So just want to re-emphasize that. I'm sure you've probably heard that before. And when we're considering the different types of attacks that we will do as a malicious mobile app user, we want to take a look at the communication options that are just available to us, right? Just sheer by the nature of how this works, even on the happy path, right? So we know that as a mobile app user, we're going to be providing input to the point of sale terminal, right? We are providing the QR code on our phone to the site system. So that could be one avenue for attack. It is also an indirect avenue for attack for those web services that will be doing some sort of processing up in the mobile application processor, so in the cloud, right? Because the site system will read that data, and then it will most likely send that to up into the cloud to the MAP, mobile application processor, and it will do something with that data, right? And then finally, it can directly attack the mobile web services. So, when you have your mobile app, it's easy to think, oh yes, here it is, it's on my phone. But 99% of those apps that are on your phone are going to be communicating with something up in the cloud, right? They're sending data to and from some server, and so by means of API or web service endpoints, and those we want to make sure that those are secure as well. So quick just run through on a QR code. It's a quick response code, just a type of matrix barcode. So all this does is a way of encoding alphanumeric characters, okay? If you had a QR, you can download QR code decoders on your phone and scan it and just see what's in there. It's not secret at all. And it's used in a bunch of different mobile payment solutions, like I had mentioned. I think probably most popular, Starbucks app. And why are people doing this when there's those EMV specs out there for contactless readers, right? Apple Pay and other types of devices that are using NFC. Well, not all merchants have those readers, right? But everybody's got a barcode reader, more or less. So this is a natural way to be able to introduce mobile payments into a merchant without having them to requiring them to upgrade or buy additional hardware. Okay, So we know that we're going to use a QR code to encode some data for this mobile payment solution. Well, what are these? What is exactly going to be encoded? So we have two solutions there. One is a one-time transaction identifier, right? So it's specific to the one transaction that we want to initiate, and it can only be used once, and it's only valid for a short period of time. These two attributes of a one-time transaction identifier sort of grew out of what we learned about having static account identifiers, which is our second option, which had very poor security properties, which I talked about earlier when I was mentioning, credit card primary account numbers. That can just be thought of as, an identifier. It doesn't change. So once you get it once, you can replay it a bunch of times, right? So that is one of the reasons why we want to move towards mobile payments, and specifically mobile payments that leverage one-time transaction IDs. Okay, so you can see that just by eyeballing a QR code, you can kind of tell how much data is in there. What we'll show in the very top QR code is just a transaction identifier. It can be whatever. This is just a single example. And then what we have below is EMV format, right? So you can still send along EMV formatted data using these types of things, but seems a little bit like overkill to me personally. But what I'm showing here is we're going to take the QR code that had the EMV data from the previous slide, and if we decode the QR code, right? So basically just change all the black and white matrix. It's going to give us, it will reveal that a base 64 encoded string. So we will base 64 decode it, and then we will TLV decode it, and you'll just see, oh, okay, this probably looks familiar to a lot of folks. What we're showing here is that, yep, we still have the track 2 data here. Of course, right now it's showing a tokenized PAN. Which is another form of a one-time transaction identifier, and then also along with the transaction identifier in the C1 tag, right? So you can send all of this data, or you can just send, like we showed on the previous slide, that A112 dot whatever, just whatever other type of transaction identifier that your mobile payment solution might want to use. Okay, so now that we know what type of data can be sent via QR codes, we want to talk about how that might be used for, the attacker's purposes. So the first thing that I had mentioned was attacking the site controller or the point-of-sale terminal software itself. And so if these are written in unmanaged languages like C or C++, then there's two types of attacks that we would want to try. The first would be trying to trigger a buffer overflow by just providing way more data than whatever that input than it's expecting for input, right? Because if we succeed, then we're going to be able to overflow bytes in an adjacent memory location, and potentially, if we're able to discover that, then we can try to do that again, but where we will insert some arbitrary code, right, which would let us get a foothold in that site control or point-of-sale software. Likewise, we can try the same thing, but using format string specifiers. So this %s, %n, these have they have like semantic meaning when it's interpreted by a program, and so it will try to fill that. But so when it's not expecting these, if there's no input parameter, then it will just fill it with arbitrary data. And so what we'd be able to do here is overwrite arbitrary bytes at an arbitrary memory location. So these are just two ways of trying to poke and prod at the site controller point of sale system from the QR code directly, right? And again, this is what the attacker controls, right? They don't even need your mobile payments app to actually even try this, right? You can just create a QR code on your phone, just even have a picture of it and go and present it. So, what are we trying to do here, just as we put this back in the focus of the previous threat model? When the attacker is going to walk up with their mobile app, they're going to present this QR code that they created, and then present it to the site system to hopefully trigger a memory corruption vulnerability. And again, the goal here is at the site system level. We're trying to get a foothold into that environment. What else can we try? Well, we can try SQL injection, right? So now the focus of our attack is not the site system itself, but what it's talking up to in the cloud. So what we would do here is send along, our transaction identifier, let's say this A12 dot something, but we're going to append a database call here, and we're going to ask it just to reach out to a attacker's domain that we control, right? So in this example, I own a server that would that resolves from attacker.com. What we are trying to do here is, again, we're going to go to the site system. We're going to present this malicious QR code. But now the site system is going to decode it. It's going to send it from site system 1 up to one of the servers running the mobile application processor. And you can see that it will be entered into a database query that says select star from tokens where ID equals, and it has our valid ID, but it also contains this database call to reach out to attacker.com. So if this were to be successful and the map were to be vulnerable to SQL injection, then yes, it would run this query. It will do the normal select from tokens query, but then it will also cause the database to reach out to attacker server. Now, that in and of itself is not malicious, but what that tells us is, hey, our SQL injection attack, it worked, right? Because as the attacker, we're going to be monitoring those web logs for the attacker server. And if we see something hit attacker.com, then we know that it could have only come from a successful database call. So now we know, okay, that worked. Instead of util http.request type things, now we're going to start poking and prodding and see what else we can learn about this database and see what things we can do from there. So this is just a first step. There are other useful payloads that we could attempt. We just talked, that example focused on SQL injection, but we could talk about OS command injection, right? So trying to get commands to run on the physical servers themselves. Blind stored cross-site scripting. Again, this is where we would be able to have it, we send this into the environment, and hopefully in some other system in the map that is presenting data, we might be able to get a user, get this attack to render in the, like a web app that is running off of that database. And then language-specific injection attacks, right? Again, we're just trying to go and target different types of technologies that could exist in the stack that are used in the mobile application processor environment or supporting web applications. And then, these are just in the examples for each of these attacks. You'll just see attacker.com/1/2/3. These are just notes so that when we're looking at the web logs, we would know, something just came in, and we see that there was a request made to http attacker.com/4. Well, then we know, out of all the different types of attacks that we have probably been spamming at the system, that one of the ones that we did for blind stored cross-site scripting was successful, right? So that's just a way of making sure that, oh, great, something hit it. How do we map that to which specific attack? You can do something very easy like that. Okay, replay attacks in your system. Of course, where the whole point of the mobile payments solution is to move away from static identifiers, because the biggest problem with them is that you get it once and you use it many times, right? So that's a replay attack. these should not work, but obviously you want to cross your T's and dot your I's. So always, whenever you're testing your system, you always want to take that one-time transaction identifier and just validate that it truly is one time, right? And that it is a short-lived identifier. So definitely want to try these. We would try these, but we would absolutely expect these to fail. Okay. Another type of attack for QR codes would be race conditions. So we know that a QR code is going to have data in it that is the one-time transaction identifier, right? And you go, you present it, and to the barcode reader. But what we want to try in this scenario is, what happens if you were to take one QR code and you had two people working together? So they take a screenshot of it on one phone, they text it to their buddy, and they both walk into different locations and try to use it. So the type of vulnerability that we are trying to test here is a time of check to time of use vulnerability, okay? And basically, it's just what we're trying to exploit here is that in any program, you're going to have a variable and you're going to check it, right? And so in this example, we're going to check to see, hey, I just scanned a QR code and it resolved to token 456. So is 456 valid? Yes. Okay, great. That's our time of check. And then we are going to, we might have some more checks, and then we will go on and use it, right? Which means send it to the system and really say, hey, this person with token 456 bought X number of goods, so let's let that transaction go through. This transaction is done. So that would be the use, right? That's when we're using it. We're sending it through. The site system is going to say, yep, we're good here. You can take your goods. You've purchased them. So what we are trying to do here is when we do a race condition, we are having attacker 1 and 2. They're going to go into separate stores. They're both going to present their QR codes. Attacker 1 is trying to buy a Snickers bar. Attacker 2 is trying to buy a bottle of Coke. They're going to get the QR code scanned. Those are going to be sent up, and it's going to say, hey, in this example, is 812.14, is that valid? Yes, right? It's going to say that for attacker 1 and for attacker 2 at the site systems that they're at. Then they're going to say, hey, has 812.14, has this been used before? It's going to send that up, and it's going to come back and say, no, these have not been used before, right? It's going to, again, say that for thread 1 and for thread 2. So then the transaction will say, okay, well, if it's a valid token and it hasn't been used before, well, then let's then let them purchase. This is a valid transaction. This should go through. So it'll go through, and therefore be marked as being used, right? So then you can see the final part, thread 1 and thread 2, token 812.14, that is being marked as being used. So what is happening on the back end, though, is when it goes truly all the way through the payment system, one of those will actually, complete successfully, and the other will error out, right? Because here's where the race condition comes in, right? So once they're valid, they haven't been used before, and they get sent back to the system, one will get there first and truly be finalized. The other one will, because you're trying to finalize on a token that's already been sent, that will error out. And so in this scenario, depending on which person's got there first, one of the person will have actually paid for the Coke, but the other person whose transaction looked like it completed successfully, they'll get the free Snickers bar, right? So that's just one other type of example that is leveraged using just the QR codes. Okay. Finally, for the other things that you want to consider when you're just taking a look at your ecosystem and thinking, okay, well, what bad things can someone do just using the mobile app as a starting point? Well, we want to say don't forget the obvious, which just means your normal web application security, good hygiene, right? So we spoke earlier about how the mobile application processor exposes web services to the mobile app to help it do its job, right? When I am driving around and I'm saying, okay, I'm in this area code, or it's sending my location data up there and it's telling me what pumps are there, that's going to be coming from, most likely, from a web service that the mobile application processor has made available, right? So I can say, okay, great, I'm on Main Street. I want to go to this station, and I can select that. And then it's going to send me some data that'll say, okay, great, there's 4 pumps here. Which one are you at? And I'll say, oh, I'm at pump 4. And then it would likely display some sort of code on the pump, or by some means have it verify that I am there, right? So in this scenario, I think, okay, well, all right, that's fine. You're just showing me a list of sites. You're telling me how many pumps are there. That doesn't seem so bad. But one scenario you want to consider here is when I say that I am at a site at 123 Main Street, right? And it tells me it has 4 pumps, and I say, okay, great, I'm at pump number 4. It is going to say, okay, great, prove to me that you're at pump number 4, right? Type in this code that's on pump number 4. For a tiny bit of time while it's showing that little random number to me, right, I'm supposed to type in, no one can use that pump, right, because it's waiting for me to type that in. So what we want to make sure is that we lessen the impact of fake reservations, right? Just meaning, sure, I can be at 123 Main Street and try to reserve pump 4. I can physically be there, but I could also be on my couch at home in another completely different state and say that I'm at Main Street 1234 site and I want to reserve pump number 4, right? And so and it's only going to hold that pump maybe for however long that device is configured, maybe 10 seconds, 5 seconds, 10 seconds, whatever. But what we want to lessen the impact of somebody who was just spamming it, that says, oh, every 10 seconds I'm going to say I'm at Main Street pump number 4, and now I'm sort of locking that pump out for use for anyone else. So this is where we talked about this. I mentioned it just in passing. I talked about QR code apps, using geolocation, right? So the devices can send data to different degrees of accuracy in terms of your location. So that is one good way to try to mitigate that type of attack. Not always 100% foolproof, but I think really we want to. A lot of the time, it's about raising the bar of difficulty, right? There's just limitations that come along with wanting to use mobile applications, mobile apps, mobile devices, and what we want to do is just lessen that risk to us a acceptable point, right? So that is, but what I'm just want to reinforce is like, oh, okay, yeah, I might not have thought about that, right? But that might have been an overlooked area if we weren't just thinking, okay, we want to take a look at these web services and we want to try to attack these things specifically, right? And find any vulnerabilities that would just exist in these themselves. It's very easy to just think about, just using the mobile app as like a happy path. So that's just one example. Okay. Now, how would we do that? Well, in order to do these mobile attacks, we want to position ourselves in between the mobile app and those web services. So you just hook your mobile app up to a proxy running on, your machine, and then, then that way you're able to see what information is sent between that mobile app and those web servers running in the mobile application processor. And like I said, standard web service vulnerability is what we're looking for. So trying to find those SQL injection, command injection, any issues with authorization and authentication. Okay, that was the first threat actor. I'll we're going to go through just threat actor of like a site controller user, right? So what happens in various scenarios if a site controller might be compromised, or what attacks do we want to consider from a site controller perspective? So, what are some ways that a site controller could be manipulated? Well, the gas station clerk, they have access to it. So if they wanted to do something nefarious, or someone convinced them to, that could be one avenue. If an attacker was figured out some way to remotely gain a foothold on the site controller over the internet or Wi-Fi, and then sort of as Mark alluded to earlier, people can go get site controllers, right? You could go buy a used one, and in those scenarios, if they're not properly being wiped, let's say, right, like clearing out specific configuration information, that might just give some interesting and helpful info to people that shouldn't have it, right? And a site controller, that's going to be talking with the mobile application processor services. It'll also be talking back to most likely whatever company made it, right? So that they can do support, and it can get updated, and it can provide helpful analytics, right? So those are the communication channels that you'd want to focus on, just to see, okay, what do we think our exposure might be here? All right. So that site system, right, it's talking to the mobile application processor, so we're focusing on this little red line right here. And we really want to talk or focus on, how do these things talk to each other? Well, they're going to send messages back and forth, okay? Some can originate from the site controller, some can originate from the mobile application processor, and they're going to talk about things. Well, what kind of things? Well, authorization, pump reservation, fueling commands, right? Hey, you can start pumping. I started pumping. Okay, great. Now I've stopped pumping. Okay. Now, this is how much you should charge me for. Please use this loyalty account to add the points to it. These are, these are the things that we want to poke and prod into. So, for security considerations, or looking at a threat model, or we want to just see, how is this communication protected? Is there transport level security? Is there message level security? So, it can be sent over the internet in plain text, or using transport layer security. Same exists for VPN, right? There could be a private VPN that these are talking to, and then the messages on a message level could be sent encrypted or in plain text as well. So what are some of the scenarios that we want to think about? Well, so one would be site controllers impersonating other site controllers on a network, and then a site controller that's impersonating, or a rogue site controller sending, or any rogue machine really on the network, sending spoofed messages, right, to interfere with just the happy path, the normal back and forth of messages that are going on in the environment. So that, ultimately, if you're able to spoof some messages, the big payoff would probably be getting free gas, right? So that's one thing that you would try to consider, in your threat model. The other could be denial of service attacks, right? So one site controller or any rogue machine claiming to be other site controllers, right? So trying to maybe confuse the normal processing between the mobile application processor and site controllers at individual locations. And that is really just, the point of that would just be to disrupt service and just cause, denial of service, like I said, so outages, the inability of folks to purchase at different locations. Okay, for the spoofed payment messages, right, a site system, when you're pumping gas, it's saying, hey, I'm starting to pump gas. Okay, and then when you finish, it says, I stopped pumping. And then it's going to say, hey, this transaction, 456, we're done. You can charge this person $20. So what our goal here is to try to see if it's possible to try to send a rogue message of that completion message, right? We want to spoof it, send a spoofed version that says, yeah, transaction 456, charge me $1, not $20. And then we want to see if we can send that message first. What happens, right? What happens when we introduce two finalized messages for the same transaction in the environment? So the mobile application, right? This is just a workflow of how this, how these things might communicate, right? So start the mobile application. We're going to initiate a request. The mobile application processor is going to say, okay, great. Here's the transaction identifier 456, and it's going to send it down to my mobile app. I am going to display that. Site system barcode reader is going to read it, and then validate, hey, is 456 real? And then the mobile application processor will say yes. All right. Then what's going to happen is mobile application processor is going to start saying, all right, transaction 456 is tied to this payment method. Does this person have enough money to do it? That's going to get sent to the payments processor. They're going to say yes. The map is going to pass that on to the site system and say, yep, Dennis has enough money to do this transaction. Going to go pump my fuel. I'm going to stop. The site system is going to say, great, Dennis just pumped $20 worth of gas. And then we have the back and forth of the completion and finalized messages and ultimately a receipt, which is going to make its way to me, the user, with my mobile app. So what we want to focus on here is right after I start fueling, can I send a spoofed finalized message, right? And what will happen when later, see if we go down, you can see consumer stops fueling. This is the normal. This is the legitimate finalized message that gets sent. So in this case, what we had observed that if you are able to get a spoofed finalized message to the mobile application processor, that whatever comes first is honored. So when a legitimate request is sent, that would be just sort of ignored, right? Like, okay, this is you're getting a update on a transaction that's officially been closed, right? So it would be the same as if I just randomly said, oh, I have transaction ID 1,000,002. Well, that doesn't even exist in the system, right? They're just going to ignore that. So since the mobile application processors closed this transaction ID, it's going to honor the $1 request and not the true $20. Okay, this is just some mock-up of the code, but basically just wanted to state here, just because some things are private, right, does not mean that they'll stay that way. So there is definitely a lot of preconditions for these types of attacks, which I will go into in a couple of slides. But when we're talking about how these attackers work, and they're going to create these programs to do it, right? So they're going to create these programs, and what we're showing here is just some of the output of some simple custom fuzzers that we had written to help us do our job, right? This is just showing, just redacted in a lab environment of, okay, here is the point of sale, or excuse me, the pump receipt showing $18 versus the mobile app receipt showing 4 cents, right? So just sort of displaying that, okay, the mobile app is going to display what the mobile application processor finalized, right? And showing that even though if you printed it out at the pump, it would say, oh, well, you pumped $18 worth of gas. You'd really, if you went and saw your credit card statement, that you were only charged at 4 cents. Okay, so these are not this is not simple. This is not an easy thing where it's like, oh, okay, yes, oh my gosh, I downloaded a mobile app for gas, and Dennis just showed me that, and this is scary, and seems very trivial to do. Well, that is not the case, right? So there are a lot of hoops to jump through. And so I just want to take a time out to acknowledge those, right? These are, this is why we do testing, but it does not mean that this is easy, okay? So what are the hoops? Well, you need to know the knowledge of the protocol, right? How do the site controller and the mobile application talk to one another? because if you're not speaking the right language, it's not going to understand and nothing's going to work. You need to know what a transaction identifier is, right? You need to know what the site identifier is, right? What's the code that represents the site that you're at? And then you also need to know, if you're trying to do this spoof message attack, so where are you even attempting to send these messages to? So you need some way to disclose that. So it seems like a lot, this info probably does not change a lot. And in most cases, I think, if it doesn't change a lot, if you find it once, it may, not always, but may, you may be able to use that for subsequent things if it's again staying static and depending on how sensitive it really is. Okay, so this is just where a little bits of info leakage or basic web app or just in general security good hygiene can come into practice. And so for transaction identifiers, we found that the site controllers generally created sequential transaction identifiers, so it's easy to brute force. So if I need to know this for my gas attack, well, I'll just go in and buy a candy bar first, and then that will tell me, oh, okay, well, your transaction ID is 2242. So I don't have to start from 0 and brute force my way through, potentially 23,000 requests. I can say, oh, well, it's at 22,442 right now, so let's start there, and then I probably only need to brute force 10 requests or so, depending on how busy the station is, to find out what the transaction identifier is. When we tried this directly at the pumps, if you do that, the mobile application processor is generating transaction identifiers, and we did not see them. Generating sequential identifiers so far as we could tell. So this is why for the previous attack I was speaking about, those always had to be started from an inside transaction. Enumerating all possible site identifiers. So if you know an endpoint for the mobile application processor and you're able to reach it, then there could be a service exposed that's just that you are able to poke and prod at to say, oh, is this a valid site identifier? Is this a valid site identifier? And depending on how it responds, it might give you some info indirectly as to whether or not it is legitimate, right? So that could, in our case, if you're providing a correct identifier, you're going to get some sort of XML message returned. If it's incorrect, you get no response, okay? So from there, you can infer what is real versus not. But again, this required getting being able to hit mobile application processor, which might be a tough first step. And why would that be? Well, we found that the mobile application processors are not returning a server or protocol banner, which means that for real life attackers out there, they would not be able to leverage Shodan. Shodan is just, you can think of it as a search engine. That is a search engine for servers on the internet. So you could say, oh, I want to find, I'm an attacker and I've got some special attacks against Apache version, making this up, 1.3.1, right? And it will return me a list of servers just out there. And because it's just out there spidering all the servers it can find, trying to see what server banners are there. Because, there are no server banners to catalog, we did not, we think that is actually a positive thing, and why that would make that harder. And the endpoints, it also, the level of difficulty could be if the endpoints require a VPN or if they're over the internet. If it requires a VPN, then you're absolutely going to have to compromise a site controller on a valid network, on that valid VPN network in order to be able to attempt any of these, right? Because that is, again, creating another hoop to jump through. Okay, so now some positive things. We want to make sure that, for spoofing messages, we might want to think about, okay, well, what's being used for authentication and authorization in there, right? So are there changes to protocols that might need to be made? How would that flow through the system down to mobile application processors and site controllers? What types of authentication should we consider? You know, XML message signing or API tokens? Do we need to create authorization and authentication at different levels, right? So tenants, you know, at tenant levels versus individual specific site locations, and those are all things that need to be considered. Another important aspect is tenant isolation, right? You've got, you know, a bunch of different sites. They may all be for the same customer, flowing up to the map. You know, you just want to make sure that, you know, either certain tenants or certain sites, you can't do something where it's like, oh, I received a message from a site controller in Ohio, but it's telling me it's trying to finalize a message for a transaction in California, right? So making sure that there is a way to make sure that, okay, you know, messages for Ohio, this Ohio site, there's no crossover with any other messages. Addressing repudiation. This really, we're talking here kind of about security monitoring. There's a lot of spamming of requests that we had to do. So, you know, if there's monitoring in there that's saying, hey, why is someone like really hitting this you know, transaction ID web service, or why is someone really spamming this site ID web service that we have, or hey, this is really weird. We're seeing a lot of finalized messages dropped, right? These might be some you know, monitoring, so reactionary, but positive things to help you keep an eye into, oh, is someone trying to abuse our system? You know, these are just talking about how to prevent these traditional service vulnerabilities, right? So want to look out for XML parsing vulnerabilities, someone trying to DOS your system by providing an XML message that is recursively defined. And so sure, it starts out as like a 1 kilobyte message, but then it will like expand its way into 4 gigabytes and draining your server's memory, right? Knocking it over. Again, you know, code injection issues, and then just trying to prevent those, and standard network security issues. So, you know, locking down any endpoints if it doesn't need to be out there, or you don't need to be listening on certain ports, and shut those down via your firewall rules. Okay, validating all the messages. So are things well formed, right? You wouldn't really expect a site controller to just up and send you a malformed message out of the blue. So that might be a good indicator. So that's on the syntactic level. Semantically, you know, just alluding to things we were talking about already, kind of in the tenant isolation. If one message is coming in from one site, it's coming from a site in Ohio, but trying to be for a site in California, you know, that's another good clue. Or things occurring out of order. Attackers always try to put, to mess with the happy path of the back and forth of communication protocols by just switching things around the order of these, and that's a good way to detect someone probing. So I focus on just 2 threat actors today. It's all part of a bigger ecosystem. There's other things and other valuable places to look. You know, based on which piece of the technology stack you're looking at, you could be trying to identify different classes of vulnerabilities in there. And so, you know, just want to revalidate that, you know, what I went over was just definitely just a piece of the puzzle for you know, the payment, for this mobile payments ecosystem.
All right, Dennis, thank you.
Yep.
Thank you for the information and the presentation. I would say your presentation was very thorough because we don't have any questions in the list.
Oh, okay.
Yeah. So with that, we'll give everybody back about 4 minutes of their day. And Dennis, again, we appreciate you presenting, and we hope that everybody will visit Conexxus.org to get more information. Thanks, everybody.
Okay. Thank you, Mark. Thanks, everyone. Bye.